Okay, here's our video on finding the identity matrix. So, identity is the key word here, identity. So, in the identity rule for normal numbers, let's say we had 2 times 1, well we'll get the same number. Right? That's what we're doing with the matrix also. And if we added, like 2 plus 0 gives us the same number. So, in multiplication, we need a 1 to get the same number. Okay, so let's have any matrix here. We'll put a matrix like this. And if I times it by its identity matrix, I'll just put an I for now, we'll get the same number. That's what we mean by the identity matrix. The same when we did multiplication with regular integers. 2 times 1 is 2. So this times the identity matrix will give us the same matrix. So how do we get that? Well, when you multiply a matrix by its inverse, you get the identity matrix. So we have to find its inverse. So for example, the inverse of half is 2 over 1, the reciprocal. Remember, we flip, and the inverse of 5 is 1/5. So that's the same concept we'll be doing with the matrix. So an identity matrix basically just has ones and zeros. That's all it has. It would look something like this, and it'll take many shapes, many dimensions. So for example, always we'll start with a 1, then we'll have a 0, and the next row will have a 0, then a 1, and so forth. What you're trying to do is, this will be a 3 by 2 matrix, 3 by 2 identity matrix. So you're trying to get ones straight down in a diagonal. In this case it ended, so you couldn't. But you can also have something like this, right? We'll have another matrix. We start with that. Let's say we had that. In the next row, we have to put the 1 there because we're trying to continue the diagonal. In the next row, we'll have to do something like that. See, we have the 1s straight down in a diagonal. It's only zeros and 1s. Do another example. Let's say we had 4 elements in a row. Again, we start with 1. All zeros follow. Put a 1 there because we're continuing our diagonal. Put a 1 there because we're continuing our diagonal. And we'll put a 1 there. So we continue the 1s in the diagonal. So that's what an identity matrix looks like. Now we have to determine which one we use for which matrix. So let's just say I had a matrix like this. Let's say 5, 4, 0, 3. And I used an identity matrix like that. Now, if this identity matrix works, then we should get the same number here. This number should be right here. This matrix should be right here if it works. So, remember in multiplication, you have to multiply and add. So here we have 5 times 1 is 5. And 0 times 0 plus is 0, so that gives us the 5 already. We have the 5 there. Then we have 5 times 0 here is 0, plus 0 times 1 is 0, so that gives us the 0 there. Remember, this is multiplying matrices that we did in the last video. 4 times 1 is 4. And 3 times 0 is 0, so that gives us a 4. Then we have 4 times 0 is 0, and 3 times 1 is 3. Add that together and we get that. So this identity matrix worked. Okay, so all you have to remember is this. All identity matrix, or matrices, they have to be squares. So for example, if you had something like this, we have a square identity matrix. If you had something like this, oops, excuse me. Right? This is not a square. So you can't do that. You have to continue until you get a square. So again, all identity matrices have to be squares. So that's one concept to remember. The next thing is, which one do you use? So if you had a matrix like this, just look at the columns. The identity matrix has to have the same number of columns. And of course, if you remember from when we multiplied matrices, that they have to have the same number of elements in the rows in order to multiply them. So this is a 2 by 3 matrix. We know that a 2 by 3 matrix has to have, again, the same number of elements in the row as in the column. So, and again, it has to be a square, so this will be a 3 by 3. And it would look like that. So just keep that in mind when we're doing the how to get the identity matrix. It has to be a square. Look at the columns. The columns will tell you how many elements you should have. So if the column is 3, then it's going to be a 3 by 3. If the column was 5, it'll be a 5 by 5. So if you had a matrix like this, what would be the identity matrix? This is a 3 by 3 matrix. Just look at the columns. It says 3, so it'll be a 3 by 3 identity matrix. And if we had something like this, what would be the identity matrix? So this is a 4 by 2 matrix, and the identity matrix has to be a 2 by 2. And remember, you're trying to get the ones in a diagonal. Again, the rows have to have the same elements. The row elements in the rows have to be the same in the columns. So again, the easiest way to do this, find the column, and that'll tell you the type of identity matrix you will make. Because identity matrices have to be square. So let's try one now, see if you can do this. Okay, try that question. Find the identity matrix. You should pause the tape. So again, we know we're looking at the columns. Let's find out what our identity matrix would be. It has 2 columns, so we know we're going to do a 2 by 2 matrix. So this times this has to equal that. Let's see if it comes out. So remember, when we multiply, we have to multiply and add. So we're going to do 2 times 1. We'll get 2. Right? 2 times 1 is 2. 1 times 0 is 0. So that gives us our first one, 2. Keep going. 2 times 0 is 0. And 1 times 1 is 1. So that gives us our second one. We go to the next row and do the same thing. 3 times 1 is 3. 0 times 0 is 0, and that gives us 3. And if you keep doing that, you'll get the same answer. So remember, the columns tell you how to get the identity matrix.